So welcome, my name is Sasse, I'm the Astronomer-in-charge for iTelescope, and with me, Leigh, our lead developer. So,
good morning.
So off we go, we're going to have an exciting time. I'm going to share my screen straight away, and let's get going. So this is a live show, it is a live broadcast, so 1 second, so that you know, so things can go wrong. Hopefully we won't be interrupted, but it's both of us. If one of us loses internet, we should still be fine. So let's jump to the main page for those who haven't been with iTelescope before. So welcome to the universe. It's so exciting. I can tell you I've been doing this for quite a number of years, but every day is exciting when you can look up into the universe, because there's so many open questions, so many things we don't know, and it's wonderful to somehow get a picture of that. That's also one of the beautiful images behind me, the running chicken nebula, by the way. So it's really a lot of fun. So when you've never been here, just read through our main page. But what you can do is you can get an account here with Join Now, and I'm just going to, then you go press Login. And when you say log in, you then come to our, what we call our launchpad. I'm just going to expand that a little bit so you can see this. So this is our launchpad where we have all our telescopes, right? Unfortunately, citing spring, where we have most of our telescopes at the moment, is cloudy. However, earlier in the morning, just a few hours ago, we did have a clear sky, and actually we've had a lot of good weather now in Australia. We've had some really poor weather, and I did manage to take some pictures for you, which I'm going to process live for you so you can see really how this is done. That's quite important. So just here's the date, the local time that you see, also the UTC time. But everything you see on the screen is always in local time. It's very important. So it's 5 a.m. It's 5 a.m. for my co-host Leigh and the other Australian who is also with us today. So it's very early, and for the people in India, it's very late. I know. So we got both extremes. It's late and early. Okay, so here you can see some data about the observatory. So usually the window opens where it's night time. This is where it's daytime. So how do we know that? If you go here on the left-hand side, you can see a map of the world, and you can see Australia is still dark. That's the dark side, and that's the light side. So I myself am in Vancouver in British Columbia, so it's up there. So you can see it's very much in during the daytime. So the position of the sun is where the true noon is. So it's the true noon. That means the sun is moving here in this direction. So as we progress, so I will soon, since my local time here is 10 past 10 a.m. in the morning, in 2 hours, it'll be exactly in, at the same longitude as mine. Okay, so, and you can see the red dots are observatories. We have an observatory here in New Mexico skies, and one in Utah. That's the new one that we have. Here's Chile, by the way, fantastic place. If you still feel like an astro adventure, take a look on our main page. I have one more place for a beautiful Chile Astro Masterclass. Just have a look there. And there is we actually have 2 dots there in Spain. I'll show you that in a moment. And then that's Australia, our big observatory. And that's the apparent position of the moon at the moment, which is increasing in brightness. We are moving towards full moon, and I'll let you know about that, also what full moon actually means. Okay, so let's jump right in. I don't want to bore you really with all kind of technical details, because that's exactly what we're trying to avoid, that you have fun straight away. So I'm going to show you also what I did this morning, so we can jump straight in. You've got other observatories here, by the way. You can open them, all the local times. As you can see, Chile is probably, I beg your pardon, Spain. That's one of the observatories in Spain. That's the other one. That's the one near Sevilla. Is probably going to be clear tonight. So that's going to be fine. It's just getting dark there. But this morning, gosh, when I first got up, the sky was clear. It was really fantastic. And I jumped onto a telescope. How did I do it? I just jumped in, and that's what happens when you click on. So you get an interface that is really the same for everything. It's just like getting into a car and driving and having the experience. In this case, it's a telescope called T10. There you can see a picture of the telescope, what it looks like, right? And you can see if there's a next reservation and so on. But the menu is on the left-hand side. I'm just going to show you what I did. So we have some information here, but the exciting part is really down here. You can see you can image the moon, and you can also press on one-click image. That's exactly what I did. So let's click there and see what I actually did. And I'm just going to try and, no, I mean, a bit of, there we go. That's a bit too large, yes. So I was looking at these beautiful objects, and you can see all you do have to do is press submit when the telescope is free. So it's really relatively easy. So what I did is I went to IC2944. That is the object just behind me called the Running Chicken Nebula. And I clicked on it. I won't do that now because the roof is closed, right? But that's exactly what I did. So all you did do is press submit and wait until the pictures then arrive in your box, right? You've got your own folder and so on. I'll show you that in a moment. That's all I did. So just press submit and you're done, basically. You're really done. And I'll show you the image processing of that. And then a bit later, I'll show you a little bit more advanced general tool that you use for imaging. But let's do something exciting. Let's do this straight away and see what I actually did there. So let's assume we press that, and just maybe 30-40 minutes later, we got some images in our box, okay? So I'm going to switch over now to here, and let's see what we actually did. Okay, so I have an Apple laptop right next to me, and that's what I was using. So at the moment, we're just going to press download my data, okay? So you come, when you say download my data, you come into a server page or interface, and you can see usually when you've done a lot of images, you'll see all your folders here. In this case, it was T10, so I'm just going to click on it. One second, sorry, here we go. And then it was IC2944, okay? So let's click on it. Here you see the date, that's today's date in, that is the night that we had inciting spring, okay? And then you see everything here. So I'm gonna make it easy. I'm just gonna click here and just say download, okay? We'll worry about what all that is in a moment, but that's the data that I actually got. It's gonna take maybe half a minute. It's just going to zip everything into one big folder. Whilst it's doing that, I'm just going to tell you a little bit about the file convention, the naming convention here. It's downloading it. It's going to be very fast. Calibrated means you don't have to do everything. Everything is calibrated for you. It's ready to process for you, right? That's a telescope name, the username, the object name, the date, the time, the filter. So we've got red, green, and blue filters where we took it to make a composite color image. I'll explain to you binning in one moment. It was a 1/22 image, and we took 3 of them. We took 1, 2, and 3. You'll see it somewhere. There's, I don't know, where's the red, and the next one is number 2, and so on. So all in all, we took 9 images. So in the meantime, they've downloaded. So I'm just going to click on this. You see, I've got as you can see, I've got a Mac here. So I'm just going to click here on the zip folder and just double click, and it opens it. And now I did a bit of practice here, as you can see. I tried all this before, made sure it would work, and it does. So this is my folder T10, the second one here, and you can see here's IC2944. That's today's date, and here are all our images, as you can see, okay? So I'm just going to sort them a little bit so you can see what they are, and I'm going to sort them by kind. So what we really need is only these. You have simple JPEGs here. For those of you who just want to use Photoshop, you can also use TIFF images. I don't recommend that. I'm going to show you a really simple way of doing this as we go now. So you've downloaded these now. So I'm going to now go into my, wait a second, I'm on the wrong, wait a minute, am I on the wrong screen? Hang on. Sorry, I'm on the wrong screen. I did the wrong thing now. I'm getting confused with myself. I've got two apples in. It happens, it happens. I'm going to just use my mouse for a second because I really got confused. What I wanted was this one. Yes. Oh, no, it's gone away. Okay, so I'm just going to just move the screen. 1 second. Let me just do this here. Oh, it's not moving at the moment. Wait a minute. Sorry, let me just do this again. Where was it? I wanted to have. No, that's not the right one. Sorry. Here we go. There is Astro Pixel Processor is here. So that's the software that I'm using because it's very simple to use. Okay, so we're just opening the software. I'm just not going to explain so much how the software works. It's really simple. So it opens, it's going to ask you for a directory. So we're just going to go into that. I'm going to go to downloads, and we had, this was our directory, and this is where our images are. Okay, so I'm going to open that too, and I'm going to create a new folder here, which I'm going to call my work directory, where our results are going to be. Okay, so let's do that quickly. And I'm saying open. So the program now knows that that's going to be the case. Okay, so I'm going to give it a quick name. So it's called IC2944. And if you like, you can even write there running chicken nebula. I really like that name. There you go, running. So all we're going to do is import these images now. So we're back in our work directory and there's nothing there. So we just need to get our images, of course. I'm going to jump into this folder again, just get our images. They're here, and here they are. So I'm going to take just the calibrated images with a fit. They call FIT. That's the convention that the astronomers use. They're like TIFF files, 16-bit. I'm just going to say open and just click OK here. And if you look here, here they are. And you can see the format here, the name. You can see it there. They're indeed from today. And all the information is there, when they were taken, and so on. I'm not going to go into details of explaining. We're going to go very fast, straight to integrate, because we're going to put them into one red, green, and blue. And the reason for doing that is really to get a very good signal to noise ratio. So I'm just going to say integrate, and it's going to go through all the steps. I've already given it a name. And now you can see the magic of modern computers. It's going to rush through this in insane speed and prepare this. So we're going through all the steps that you don't need to do. We already normalized, and there we go. And we're basically done. We've got now 3 images, blue, green, and red, and we're going to combine these in a color image. So the reason for doing all this was to really reduce the noise and get good signal. So let's go straight in and see what we got from this very simple run. I'm going to go here to just combine RGB. That's what we do. Now we have just an RGB, just to be a little bit pedantically accurate. You could also just leave it like that. I'm just going to say it's an RGB, and we're going to import that. It's right in our work directory, and here are our new images. So I'm just going to say open, and it's just going to associate a color channel with it. And all you need to do now, first of all, is click on saturation here so that we get a color image there. I'm just going to do that and say calculate now. And there we go. And we already have quite a beautiful image of the running chicken nebula. You have to think this morning was even a little bit cloudy just before it ran in. So just from, what was that, 369, what is it? 9 times 3 is 27 minutes, not even 30 minutes imaging in total. That is quite a remarkable result. So let's just improve this a little bit. I'm just going to say save here. So it saves it now as an RGB image. Okay, I'll do that. I'll say cancel. And let's just correct the star colors a bit. So the only other thing you need to do is just say calibrate star colors. Here's my RGB image. You can see it. I'm just saying open. And it says, well, before you do any star color calibration, you just have to remove the gradients, some color gradients in there. And that's easily done. I'm just going to really hide. Here's your screen you know, just the preview. You can see there's got a bit of color gradients here. We'll correct that. And we're just giving it some samples of the background here, which should be equal. Okay, I'm not going to explain all this right now because that's not that important. I just wanted to really demonstrate that this is real what we're doing. It was a real control of a telescope, and we did real imaging here. You know, it's not something that you're letting. See how beautiful it did its correction. It's removed the green cast. Actually, the green cast is gone now. It's gone, given quite a beautiful result there already. I'm just putting the contrast a bit better and just say okay and save. So we'll save this with the correction, and now we'll just. The question is, what is the true star color here? So I'm going to take a sample of the background here. Let's take this, for example, and let's see if we can get, it's going to sample it, and it knows the distribution of colors in our Milky Way. So it's, wait, is it doing it now? Oh, no, sorry, I pressed OK and save, my fault. I meant recalculate. That's what I meant. Here we go. Okay. So it's now taking a sample, and that's actually already quite good. I'm just going to increase the saturation a bit, and you can see the colors are actually coming out quite beautiful here, right? So you can make it even a little bit redder, but in just this short time, you can see this very bright, intense star there that is causing a lot of this beautiful emission nebula of the running chicken nebula. But you can see how beautiful the yellow, the blue and the red indeed came out. And that's basically it. I can say save now, and you save this as a TIFF image, and you're done. That's it. That's it. So hopefully that gave you a little bit of appetite that this is not that difficult, right? It's not. So I'm going to go away again from this, and let's go to the next step. Actually, you're going to say, well, that's nice, Christian. If you have these choices here, you know, you have some menu, but what happens if you want to plan and you don't really know what you're going to do? So let's just go back to the main page and go through these steps. Okay, you see here it says start planning here. So let's click that, and that's your iTelescope planner. And it gives you different observatories. So let's try and reconstruct what I just did. So this was in Siding Spring, right? So I'm just going to click on search here, and there you go. Here are all our possibilities. Now you can see a lot, but I want to just redo the running chicken nebula if you would not use the very simple starter menu, but you wanted to do a little bit more detail. So let's concentrate on this nebula right here. Okay, so you can see here quite a lot of information that's useful. You can see how far the moon is from there at the moment, the magnitude that gives you something about the brightness. I won't go into details now. And this is the most important. What is the rise time? This is the highest point. We call that the transit. And what is the set time for this beautiful nebula, right? So you can see it's visible all night at the moment, which is really convenient, right? So that's also why I chose it. So if you want to have a go at this nebula, it's a very good time to do that. So what you do next is you just click on Telescopius, because you don't know what telescope you're going to use, right? We have no idea what we're going to use. And Telescopius is a fantastic site. It's free. I strongly recommend it. And you can see we are in Siding Spring here. Sometimes there are browser issues. I just have to warn you, and it may jump in and out. So in that case, just click here on the observatory where iTelescope is and choose the correct observatory. And sometimes you may have to go in the in private or the incognito mode to do that correctly if it jumps back. What is very interesting here on the right-hand side is you can see the visibility of this object, and you can see that's daytime, that's nighttime, and the red curve is really the altitude projection as a function of time that you can see there, and that's the highest point. So what it's telling you, you can see this all night, and this is the 30-degree line that I've defined. So you can see this 30 degrees is usually what you need in order to have good conditions, right, to see the object. You can see, we can see this all night. Now, what telescope are we going to use? And this is where this virtual viewer here, this field of view, comes in very handy. You can see it's already clicked on iTelescope, and here in this, on this icon, you have all the choices for different telescopes. Now, we did choose Australia, but the Running Chicken Nebula, depending on its where it is, could be visible also in the north, but it's not, because it's got, this is like your latitude's minus 63 degrees, so you won't be able to see this on the northern hemisphere. But some objects are, and that's also why you can see that. But let's stick to Australia for a moment. So here's the wonderful Australian flag. So I'm just going to click on it and just see what this looks like. Okay, so this would be T59, and you can see this must be a big telescope. Gives you just a small, just the inside, like something that I've got and the back that you can see of the nebula, right? That gives you the core of the nebula. So the field of view is only 0.61 degrees, so that's fairly small. Now, if you wanted to have a larger view, we would have to take a different telescope. Now, this morning, sorry about that, I was taking T10. So let's find T10 actually. There it is, T10, and see how that actually looked. So that's exactly the field of view that we got, that was taken for the Running Chicken Nebula. So it's perfect for this view. And you can also choose one of our one-shot color cameras if you wish to. T69, there you go. And this actually gives you the whole thing, just not in filters, but as a single picture, right? Also beautiful. So you don't have to do the red, green, and blue combination that I've just been doing. Okay, but let's stick to T10 for now. So because it fits into what I was just demonstrating. Okay, so you know now which telescope to choose just by looking at the virtual field of view. So we've done that. So we jump back to our main page now, and let's say we go back to T10 like we just did. And I'm jumping right back into it, and this time we're going to take the more advanced menu. Okay, so we took one-click images. The most important one you're really going to use is deep sky objects, right? So again, we have to say, we have to now give it a name. Okay, you just give, I'm just going to call, you can call this whatever you want to do. So I'm just going to call this Running Chicken. Okay, let's just call it Running Chicken. That's fine. And then you want a name, you can either call, put in a Running Chicken, or you can give the catalog designation. We know it's IC2944, so I'm just going to say, look it up, and it found it, you see. And the nice thing is it tells you again what the start time is, the transit time, and the end for your imaging time, right? Tells you all the details that you can, in this case, use it all night. Oops, that was unintended. 1 second. Let me just go get this. What did I do? Let me just get back here. Okay, there we go. Okay. So you can go back and even look at the framing. I won't do that now, but you can jump backwards also and look at Telescopius, what the framing is like. So it's all filled in for you, and all you have to do now is fill in the fields here. So we had different filters. So I just want to take a small excursion what filters are about, so that we can fill this out correctly. Okay, so usually this is what a filter wheel in a telescope looks like. You have to imagine that the cosmos, or the universe like it is behind me, is actually very faint. So we need long exposures, and that's why we prefer to take different colors, which we can then combine, right, and do longer exposures. And this is a camera. As you can see, this is where the telescope would be. So typically we would have red, green, blue, and also luminance. Now, luminance is like your black and white filter that covers everything, right? It covers the whole spectrum. So that gives you really the contrast. We usually have other filters too. Those are narrowband filters, though this is a 5-position filter wheel. Usually you would have 7 positions so that you can fit in the narrowband filters too. So what is narrowband? Let me just show you that very quickly. So we have the red, green, and blue filters, which really cover the continuous spectrum, which we then combine like we've just done. That's the continuous spectrum of very high emission nebula. But at the same time, these nebula also have certain emission lines because they're quite thin. They're very hot. They're excited by hot stars nearby. And the typical emission lines that you would see is the hydrogen alpha. Hydrogen is the abundant element in the universe, and it's really in the visible. It's quite red, this line, and it's very clear. That's also what makes up a lot of the image behind me. At the same time, you get other elements in such a nebula too, and one of them is sulfur. It's it's not so dominant in the one that I have behind me, but sulfur is usually also one that you would take. And oxygen is more the bluish color that you see there, blue-green color. And those are what we call narrowband filters. And if you combine broadband and narrowband, you get beautiful results like what I've tried to create behind me. It's just really a piece of art, and that's what makes astrophotography so much fun. So one other thing you have to know is something about binning. So binning is when you combine pixels. So that's not usually something that you're used to, but the way this is done is you have your sensor, and you have those are huge sensors that we have nowadays, just like your phone, your smartphone has a lot of sensors. We have that too, and each of them is like a single a single camera, you call, but we combine them all into one single image. But we can combine these pixels together to give it more sensitivity, and that's called binning. And that's really an electronic process, the way we read out the chip. So it is, in this case, we're combining 2 by 2. What benefit does that give us? Well, if we have red, green, and blue, it gives us more signal, because we're getting suddenly 4 times the signal that we would get otherwise. Now you can do more binning, but in general, 2 by 2 is the most recommended one. So for red, green, and blue, we would use 2 by 2 binning to give it more signal. We lose some resolution, as you can see, because our area is getting larger, but that's nothing to worry about. And the reason why this is nothing to worry about is we also have the luminance filter. The luminance filter, we're not going to bin, we're going to get the complete signal. It's like the black and white signal, okay? So now you know enough to go back here and fill in these fields. So I'm just going to put in 1 luminance for now, and you can put a time here. Let's do exactly what we did in the other 180 seconds, and I just explained what binning is, and we can fill out the rest here too. That is the red. We'll do exactly the same there. Now we're going to choose binning 2, right? That's the key thing, and we will just copy that for green and blue. So we'll do that, and that would replicate what we've just done, but in addition, what we also have is the luminance. So indeed, our image would look a lot better. So this is all you need to do. Now, the nice thing is you could increase the quantity here, but there's a better way of doing it, is the repeat function. If you enable this here and you repeat this 5 times, let's leave it at the default here, 5 times. So you have 5 times 3 is 15 minutes per channel, right? 15, 30, 45, 60 minutes in total. That's going to give you a much deeper image than the one we've already done. So longer exposures you can always add on. That's the nice thing about telescopes, right? The objects appear next day, you can just add this on. So you could acquire images now if the telescope was available, you could do that. But let's just create the plan for later, and let's assign it to the telescope. So there it is, it's saved now. And let's just jump in and go back to the reservation, because what we're doing now is we're going to find a free night where we can actually do an image and just run that. So where are we? Wait a minute, where's my reservation? Here, make a reservation. You see that? Let's click on that. Okay, so what you see here is, oh, this is great. There's nobody using the telescope at the moment, which is a delight, because when there is new moon, it's really quite populated. But this is great, let's just do it. So I'm going to, let's take Saturday. And because it's visible all night, I'm just going to click anywhere with my mouse and just open it here. And there you go. And the window opens, as you can see. That's my start time and my end time. Now, we know that it takes 60 minutes, but the telescope has to focus and do all kinds of other dances before, there are a lot of things it has to do in order to give you your picture, slewing and many other things, right? So usually what it says, the recommendation is to use 1.5 times the amount of time. So we're going to do that. We're going to give it a 12:30, so give it 90 minutes. And now I have to select a plan because it's saying which one, because I may have several plans. Here's my running chicken. There you go. And that's it. Now we can put a comment in here. And you can also reschedule for other times. So I'm just going to say confirm reservation. And there it is in golden color. Usually the other ones are, I forgot what color it's, blue or green, doesn't matter. I think it's bluish. But yours is in golden color there. And there you go. And you can even shift this around now if you want to, or to go to another date, right? So that interface does it. And, if everything runs correctly, that's all you need to do. Your images are going to be in your folder, and hopefully you're going to be happy and just have a good processing time and just, really increase your knowledge about the universe and also the imaging. So I've shown already how to download them. So that's great. We don't have to do that. And actually, I think we really managed that in a very short time. So I'm just going to show you a few other things about pricing that is quite interesting. So we start at plan 40. Plan 40 is $40 per month. And that gives you a lot of value, actually. So you can see here the typical prices that you have per hour here, and you get 40 free points running to it. And then you can go to the higher plans. The higher your plan is, the more discount you receive. And what is very nice also is now full moon is coming. So if you come, you can go to full moon happy hour. It's really a full moon happy hour in the truest sense that it should be starting very soon, isn't it?
No, it started yesterday. Yeah.
Oh, so thank you so much.
Yeah.
So we're running it. So you can run all these things for free, basically, which is unless you do a reservation. But here you get a little bit of explanation here about about the full moon happy hour. So if you just jump in, like you do in happy hour, you just come in. The telescopes are free for the 10 days, which started yesterday. Great time to actually start an experiment. And it's maybe not the best time to do RGB, but for narrowband, have a blast. You can test it. And maybe you could say a little bit, I'll give you how long the time is. Maybe Leigh, can you just explain a little bit more on this?
Yes. So during full moon happy hour, you get 1 hour of imaging. That is not exposure time. That is 1 hour of telescope use time. So that's equivalent to session billing. So you get one of these sessions, one telescope, pretty much per night. It's actually technically every 18 hours. And the reason why we say 18 hours is if you were to do an imaging session later in the night, your local time, it means that the following day you can take another imaging session earlier on in the night. Yes, so with reservations, you get a 25% discount. But if you've see a telescope available and you want to image on that telescope right now, you get 1 hour for free, while the moon illumination is above 75%, which equates to roughly around about 10 days.
Thank you.
Thank you. Yeah.
So I hope it's clear. So have a blast now. By the way, I may have said before, I'm just seeing the comments right now. So it's still we now have Utah remote observatories. Thank you, Sikanda, for pointing that out. It's not New Mexico, it's just my head. So sorry for that. So yes, and it's a beautiful observatory that we've partnered with Utah Desert Remote Observatory, and it's very nice to use. What I also wanted to point out to you is so yeah, do test that. Let me just see where my 1 second. Let me just hide this for a second. because it's in my way. You can't see that it's in my way, but let's go here. Yeah, we have this beautiful iTelescope webinars, right? So this is, oh gosh, sorry, that's Spain. Open the roof in Spain. That's always my alarm. Okay, maybe Leigh, you could quickly do it. Thanks, if you don't mind.
Yeah, sure.
Thank you. Okay, so this here is, so we've got over 30 webinar on YouTube. I'm just going to put this into the chat so that you have the link. So you get a lot of educational videos. This one's also going to be posted there. What's very nice, we got all these young students that you know, that come every Friday, and I'll give you the link to the webinar page too. But it's very educational, it's beautiful work that they're doing. And also thank you to John, Walter, Sikanda's also here. I've seen, and John, I think John, Walter also here, who are helping to make these and post-process these, that they get so nice. There's one I really would like to draw your attention to. Sorry, not the commercials. Let me just go a little bit forward. Let me just get through this very quickly. 1 second. There we go. Skip ads. This is Charles Bracken. And what I wanted to make you aware of, we have all these comments underneath here, but Charles Bracken, let me just go spool forwards to where he is. So he's explaining there just a few weeks ago, and I'm going to give you the link to this YouTube video too, so you have it. Also gives a telescope planner, and it's beautiful because it's a special planner. If you don't know what objects to take, what targets to take, listen to this beautiful video that he's done. And also there is a link here to the planner, which I'm just going to give to you. Here it is. And I strongly recommend that. I think it's less than $20, but it gives you everything. It's just beautifully written and gives you all the details of the observatories that we have and the targets that you can image there. It's not the observatories we have, but I mean the targets that you have at the observatories. That I can strongly recommend. Then one other thing I also wanted to point out to you, which you also get as part, let me just go back to our main page here. 1 second. I have to find our main page. Okay, I can't find it at the moment, doesn't matter. Oh, there it was there. Okay, go back to iTelescope. Is premium images, because it's every 14 days and it's coming up to full moon, so we're getting new images. Images are released a whole set for you. And depending on your plan, whatever plan you have, the higher your plan is, the better resolution you get. So for example, if you have plan 160 to plan 1000, you get all the incredible narrowband, which takes many hours to take too. But this is very nice because you have complementary images that you can just use all the time, every 2 weeks, and you can do a lot of practicing. These are taken from very good telescopes, like the 20-inch telescopes and so on, and this was taken in Chile and so on. So, and there's the next announcement that comes through. Right, so I'm just going to stop sharing, and I will stop the recording here, and then we'll go to the questions and answers.